Alright, for our next video we've got a Yamaha A700. This amplifier is actually in just for a restoration. Works fine. It did work fine before shipping. We're going to test that out before we get into it. These Yamaha A700 and the A1000 are probably two of the best integrated amps of the 80s, and then honestly probably they're pretty much just some of my favorite integrated amps, period. I've been running an A1000 in my system for quite a while. My father had one brand new since '86. They're just great. They sound great, have a lot of power, can drive difficult to drive speakers. I'm running a set of B&W 804s on mine, and yeah, they're pretty cranky. They get down to mid 3 ohms and some frequencies. So yeah, they're really nice amps. The biggest issues these guys have is they will have some weak capacitors, lots of bad solder joints, so you'll have weird intermittent problems. And they used the corrosive glue to hold on some of the capacitors when they were building these things, so you'll end up with, eating off legs of transistors, resistors, diodes, sometimes little capacitors. So it's a pain. The A700s seem to suffer from it way less than the A1000s, but they do still suffer from it. So I've got this thing, I haven't plugged it in or turned it on since it came in. So I've got a dim bulb tester hooked up right now. I'm going to plug it in. Well, I did plug it in, but I want to turn it on. And let's turn the scope on. Let's see. I'm going to turn the scope on. We're going to do some bass lines. Just want to make sure it doesn't have any weird noise. Doesn't have, I don't know, anything. First we're going to turn it on. So let's turn it on right now. You get to do it with me. So we'll see if this light, dims up. And then we'll see if the protection relay closes. So here we go. There we go. And hopefully you'll hear a click eventually. Still waiting. Yeah, there we go. So cool. So yeah, this thing appears to be happy. So I'm going to cut it off again, and then I'm going to plug it in directly, get rid of the dim bulb. Again, if this is if it hadn't gotten shipped and it just came from someone's house, I probably wouldn't even bother doing this. It's just that if something got knocked loose and damaged in shipping, I don't want to end up shorting all the guy's outputs out or damaging something else because, something we could have seen. Let's see here. I'm going to plug my phone in. I got my phone. We're just going to use this as a signal generator. I don't feel like digging the signal generator out just now. We're just going to throw 1 kilohertz test tone through it anyway. And let's see, get that up. Let's use this program here. It's just an app for signal generation. So I'll turn it back on. Relay should click eventually. There we go. So I think I have an auxiliary. And let's see, go hit play. Let's see here. Let me pause and I'll be right back once I actually have a waveform up. I'm not sure what I did or didn't do here. Maybe this is it. Huh. I'm not sure. Let's see. What do we got? Yeah, this isn't happy for some reason. Let me see if I have everything hooked up right. I'll be right back. Yeah, so there we go. Basically, operator error. Toss this thing in the closet, and all the probes was on 1 time, one was on 10 times, blah 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 blah. So So there we go. Let's round up the clipping. Turn my phone back on before it goes to sleep. There we go. So we'll round it up to clipping, and we're getting right around 84 on one channel, 78 on the other channel. So we wiggle the selector, you'll probably see it get a little better, and wiggle the balance, probably get a little better also. So we've got a couple of volts in balance, could be the thing. So let's say basically high 70s, low 80s, peak to peak, unrestored. Let's see, low volume, I'll turn it down a little bit. I'm just going to run it low. Let's see if we have any noise. I don't see any noise. So it seems pretty clean. Let's turn it down even more a little bit. Nope. So yeah, very low voltage. You've got, it's nice and clean, which is what we want. Let's turn it down again. Yeah, so we're running it nice and low. It's clean. So that's good. So I'm going to shut this off. I'm going to hit stop here. Kill that. So flat line. We've got no noise at all. This is exactly what I like about these amps. This thing off and on basically sounds the same. You might get a touch of hiss, like full volume if you stuck your ear next to the tweeter when it's quiet. But yeah, these are amazing amps. They're really nice. Worth putting the time into and the money. So I'm going to pull this cover off. I'm going to try to do it one-handed. So I might fail. And if I do, I'll just pause it. So when you're doing Japanese amplifiers, I recommend using a Japanese screwdriver. It's a vessel. It fits in the GIS screws perfectly. So you won't end up with ugly looking screws all marred up and nasty. You'll notice that the screws aren't screwed directly into metal in this thing. They're screwed into inserts, which is really nice. The A700 is rated at 100 per channel. The A1000 is 120 per channel, I believe. 120. And it uses a dual voltage power supply, where when it hits a certain voltage, or when it hits a certain load, it jumps the voltage up to the next. I forget exactly what they are right now. So here's the next one. I think I might be able to do this. Not looking like too much of an idiot. Alright, let's see. Is there more? No. Okay, there's that. It's difficult. Let's go for a ride. Okay, we made it. On the floor, I'll trip over it in a little while. So there we go. Here's the inside. Let's drag this light over. And let's see, get some focus going on here. These are Toshiba outputs. Nice. Another set over here. Drivers. There's your bias transistors. These guys you have to be careful with too. They get brittle with age. I do have a substitute. I might put them in here. Let's see, move that out of the way. Move the light over here, and you can see right there. We got green fuzzies on those resistors, and those Zener diodes too. I forget what they are. I think they're 16 volt Zeners. I don't remember. So basically, I'm going to change both of those Zeners for those resistors. You go on this other side. Move this out of the way carefully. You've got. Similar story on this side too. There's a jumper, resistor, it's cruddy, another resistor is kind of cruddy. And honestly, on this one, that's about it. You'll have glue right here, but there's nothing underneath it, which is nice. The 1000 has a board on the side right here with all the inputs on it, and it has just, it's glopped on there. It's disgusting. Takes, I think I replaced 30 components on mine when I restored it. So otherwise, other than that, you'll have these resistors will get wiggly. Oh, they're still hot from running it. This does not seem that bad. It's good. Depending on how much time they're run and how hard they're run, I think you'll have these transistors will be wiggly. Which this one's not bad. So this one actually seems to be in fairly nice shape. It doesn't seem like it had a ton of hard use on it, which is nice. So what I'm going to do is I'm going to tape up the side. Yeah, it's still on. So I'm going to shut it off. I'm going to tape up the side right here, and then we're going to light on its side. I don't want to. This one's in nice shape. The finish is really nice. A little dirty, but I don't want to scratch the. You'll see, it's kind of a rough finish right here. If you're dragging it on the counter, you can rub the anodizing off. So I use masking tape on the side or gaff tape, something strong. So we're gonna dust it off a little bit. We're going to do that. We're going to check these capacitors in circuit. I have one of those cheap Chinese testers. They do pretty decent in circuit. Yeah, like I said, this one actually, you'll see the glue is kind of orange still. The glue, when it gets really yuck and corrosive and nasty, it's dark brown. Kind of like this is a little darker brown, where those other resistors are pretty bad. That's kind of what it looks like. It gets worse. Like I said, with mine, there was legs just completely missing off of capacitors and resistors and all sorts of stuff, so it was pretty bad. But this one, the guy sent it to me because, you know, he really likes it, which I don't blame him, and he just wanted to make sure it wasn't gonna fail. So when we test caps later, these will be bad. These will be bad. These will be bad. These will be bad. These are always bad. They always test bad. Never had a set test good. These little ones, we're going to go ahead and change them because he spent a decent amount of money shipping it here, so there's no reason to do a half-ass job, really. I mean, if it was down the street, I would say, yeah, leave the little ones in there, save, 20 minutes of time, but why? I've got the desoldering tool. It's not like it's going to take me very much time to get at them. It's kind of silly to do that, There's only, there's a decent amount of capacitors here, but it's just not worth. And if you're going to restore it, restore the darn thing. If you don't, if you don't want to restore it, then get it going again. We can get rid of the glue and just replace a couple of ones that I know test bad. But yeah, if you want it to be brand new again, we're going to do the caps. We're going to replace these open frame pots. These tend to be iffy. The ones in the Yamahas aren't that bad. Like I did a Techniques not too long ago. Those were kind of crappy. So, but the thing is, the Borns again cost $3, something like that, $3.50 I think. I don't know. So you get nice multi-turn pots to set the bias, which is so much nicer. This is your Auto Class A. This has an Auto Class A circuit. You turn it on. I think it's 3 or 4 watts on this amp, and this sets the time when it shuts off. It really doesn't. I mean, I don't use it on mine. It makes it heat up, and I can't tell too much of a difference. Some people really like it though. Maybe they have better ears, and maybe their speakers are a little different. Who knows? It's a nice feature to have, I guess. And you'll see down in here, there are a few more caps. Not too many. I'm probably gonna end up taking this cover off, or the front panel off. I think I will, and waxing it, make it look all nice again. Because, might as well shine it up while it's here. So that's what we got going on. So I'm going to, like I said, I'm going to put some tape, basically any painted surface, put some tape here, put some tape here, and then we can roll it on the side. What I'll do first is, I'm going to yank these, and I'll yank the damaged parts. We'll put them back in, we'll do another test, make sure everything's happy. It will be happy, but just in case, and I'm going to get rid of this glue. I'm going to spare you guys the details of the glue. Basically, the glue spritz a little acetone on it, use a chopstick, scrape, 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 a little more acetone, chopstick, scrape, scrape, scrape. When it's new like this, it's a pain in the butt to get off. It's the only thing better about the glue when it gets all hard and dried. It kind of just flakes off and disintegrates. But when it's newish like this, you know, you've been spared damage to anything, but at the same time, it's like, it's still really sticky. Alright, here we are with our load of parts. So we've got a bunch of capacitors. We're using, here's our 16 volt Zeners, 27K resistors, replace the gooped up ones, new relay. Luckily these relays are still readily available, and Yamaha likes to use these relays in a lot of things. I've got a B2X, uses the same relay, the A1000 uses the same relay, M60 uses the same relay, M80, millions of things. So if you're looking for one, here's the part number for it. This is the Mauser part number. If you get rid of the 653 in the beginning of it, it's the same thing for DigiKey. They're probably like 10 bucks a piece. The Matsushita relays, whatever they're called, that they use in here are, they don't last very long. They seem to have a lot of problems. So I've got a B2X that's pretty much new, and the A channel or A speaker terminals, they don't even work. I still have to restore it obviously, but yeah, the relay is bad enough where they don't even pass no sound at all. The B passes one channel, the left I believe, most of the time, but not all the time. So yeah, that thing needs to get restored. That's it. I have an A1000, I really like it, and I don't know, it kind of makes me not mess with the other thing. I have the C2X that goes with the B2X. It sounds good unrestored, but it's a big project, and you know, like I said, after I restored the A1000, I haven't really bothered. So yeah, we've got the actual factory service manual for this thing. I really like the factory manuals. I like to pick them up if they're amps I like to work on. So this is one I do like to work on. I've had one of these. The A1000 I've got 3 of, plus the Japanese market version. It's called the A950. So yeah, I've got, you know, quite a few factory Yamaha service manuals. There's the B2X, the M80, M60, 460. I had one of those a while ago, got rid of it. Here's the A1000, C2X, C80, had that. T80, T1020. And there's a bunch of owner's manuals for stuff. So, yeah. Like I said, I'm a fan of Yamaha stuff, so I like to get the literature that goes with them. So yeah, so here we go. You use this to bend the resistors and the legs on the Zeners. The resistors I'm using stack pole flame resistant. If you're doing restorations, use good resistors. You know, buy a pack of those junky Chinese ones for when you're chasing down a problem and you need some crazy value resistor that you're not going to stock. Then you could pull one of the cheapy ones out, stick it in there, you know, get it running again. But then when you're done, take it back out, put a real one in there. So I decided to go ahead and take the face off, just so I don't have to bother. I'm going to still tape it and everything. These things come off too. But I'm going to clean it, like I said, when we're done. So yeah, I took the face off and put some tape on the side. So I'm going to take these off and replace them. And that's going to be it. We're going to replace the big caps. I believe they're 1000 microfarad, right? Let's see. No, 680 microfarad. We're replacing them with these. These aren't audio caps because they're not in an audio path. They're actually local filtering. Yamaha likes to use a lot of local filtering, which is really nice. So you have your main filters, which most amplifiers will just use main filters, and then every stage, you know, feeds off of them. These guys let pass a little bit of ripple. So what Yamaha likes to do is, for various stages, they get their own filter caps. So you'll have, you know, these are for amplifier stage. This is for, I believe this is for the tone controls. Maybe this is for another amplifier stage. I forget. I'll have to look at the schematic. But yeah, so they use a lot of local filtering. I think they called it current dam or something like that. So basically, you know, under high current conditions, everything has its own reservoir of current, rather than relying on the filter caps to try to take up all the slack, which is nice because, yeah, it keeps the distortion down. These do take a beating though, and these Nichicon, what are they? The UPJs. These are a power supply cap. I believe they're rated for like switch mode power supplies and stuff. They have a high ripple rating, high life rating. They're perfect for this application. So you know, people like to replace everything with Elnas, the Silmix or whatever, everything in every spot, or you know, Feingold's in every single spot, but they don't belong in every single spot. They belong where they belong. And you know, if it's a power supply, if it's a high ripple thing that's going to see a lot of ripple, you know, you want to get a cap that's not going to crap the bed after a while. Like I said, I'm going to put these in the tester when I take them out. I'll show you guys, but these will be bad. These will probably, I mean, this amp doesn't look like it has a lot of hours on it, but the last one I went through had quite a bit more hours, and these were down to 300 per side, so half. And like I said, these plastic case guys always, they never test very well. So yeah, like I said, these need to be replaced, and need to be replaced with a proper cap, not just any cap. So yeah, that's basically the plan of action. Now we're going to do the caps, we're going to do the glue, we're going to renew the heatsink paste, we're going to do these trimmers, and just a general cleaning. And we're just going to, you know, I'm going to go over the bottom of the circuit board with the magnifying glass, eyeball some joints. I'm going to retouch these anyway, just because these always fail. They didn't use enough solder, I don't think, on these. They, I think they did the wave soldering maybe when they were kind of first trying out a new method or something, but these have a tendency of developing a lot of bad solder joints, so I'm trying to head that off at the pass. I know these transistors that get kind of warm, those bigger guys there, they'll get loose in their sockets, and you'll flip them over and you'll see them just kind of hanging, and there's not very much solder on them, so I usually pull the original solder off with that, because mixing, you know, cruddy crystallized old solder with new solder kind of works, kind of doesn't work. I'd rather just replace it totally, get a nice fresh, nice piece of solder on there. It's got 6048 Kester with the 44 rosin, or I have a Worth. I forget what the heck it is, but the Worth actually flows really nice. It's got a nice mild rosin, but it coats really well, so either one. One thing I said I was going to do that I forgot, but I remembered once I flipped it over. Test the main filters with this tester. This guy actually does a decent job of in-circuit testing. I believe it usually tests a little bit low in-circuit, probably because there's a bridge rectifier and everything else in the way, but because I've pulled these out before and they usually test a little bit higher, but they usually test well within the 20% tolerance, so let's go. Let's see, it takes a little while for it to test, but I'm guessing they'll probably be right around 20K. The last ones I did were right around 20K also. Like I said, one I did pull out, I think it got up to 21K after I pulled it out of circuit, so well, they do decent in circuit, they're not perfect, so let's see, 19.8, so that's good. That's very good. Let's check this guy. Let's see. Sorry about the glare. There we go. Better. $19.3. Okay, so they're 22,000 microfarad caps, so they're within tolerance. That's, like I said, just about average of what I've tested these, and actually kind of average of what new caps test anyway. They seem like the newer caps are really taking advantage of that plus or minus 20% and leaning on the negative 20% side more than you would want. So yeah, these are fine. I didn't do a leakage check, but I would imagine that they're fine. Yeah, I haven't seen these actually go bad in these yet, and especially this one with these little hours as it looks. So here's the underneath of the board. Got a bazillion solder joints. They did a lot of underneath connections, which is interesting. I've never actually had to do any work where I need to remove these, thankfully, because this looks like it would probably suck. So thankfully we don't have to do any of that again. So you'll see some of the joints are kind of grayish. Let me see if I can find any good ones. close up for you. This one's not doing a good close up. Man, this lighting sucks. I'm sorry. Let's see. Can't really see it very well, but that joint on where is it? This right here. It's kind of like ringed. And this is the main bus. So we've got our two caps that we're replacing. And a bunch of junk that's going to get replaced also. And then this is the main bus. This we're going to pull out because it's got corrosion on it also. And we'll also renew obviously the solder joints after we're done pulling it out. I'm going to polish it up, make it look nice. And then just getting all this junk out of the debris field helps a lot to clean. You'll see this one's kind of shitty looking too. Let's see. Yeah, that's not a very good looking solder joint either. So yeah, like I said, these are all going to go. Everything that's been touched with the glue. Yeah, let's get these main caps, or these bigger caps out of the way, and then these other corroded things out of the way. And then that bar. Just nice amount of room to clean and clean up that glue. So I'm going to start pulling stuff. I'm going to flip back over. I'll show you guys real quick what we're looking at, and then I'm going to get at it with the acetone and a chopstick, and it'll be fun. Alright, here's what we got out of there. We got a couple diodes. Well, one diode went flying someplace, but there's two like that. These are some jumpers. Kind of nasty resistors. So one thing you'll notice on these sometimes when you're desoldering, the solder is not melting, it's kind of turning into powder. And that means the corrosion is kind of eating down the lead and through the holes. You can see the debris field here. It's kind of nasty. You can see where we took the bar out. A couple jumpers. I think I might have to take another. I don't have to look at those other resistors. That one might be dead too. It's standing up, fusible. Those green ones are standing up. They're fusible resistors. I'm going to have to pull that out and check out the lead. Probably have to replace that one too. So maybe this one also. I don't know. I'll have to clean it. But yeah, so once you get that green fuzzy corrosion, you're in pretty good trouble. That means it's about to. You're not really making contact at that point. So let's test these caps since we got it out, right? Funny part is the caps that this glue is all for, don't ever have it on the leads. They're always fine. They just destroy everything else too. So 634. Wow, this is definitely the best one I've ever tested. Like I said, the ones I usually test are far below spec. This must not have much use on it, this amp, which is cool. Did it restore? Yeah. What did I do? Let's try again. $641. Well, it's below. Let's pull these other ones and we'll check what we're putting back in. Let's see. It's gonna be a little harder to do. Got one long lead. This thing's driving me nuts. There we go. It's not gonna help, is it? I need better lighting. I need better lighting. I mean, I could see what's going on, but that's not helping the whole purpose of a video. Alright, that should be good. Let's see. At least this thing lights up. $680, so this one's right on the money. They come in this really purple, pretty purple color. I like them. They work nice. Alright, let's try this one. $681, they test exactly the same. So, yeah, so we're taking these out of spec guys out. They don't feel very substantial. You go like this, they're very light, and you do it with these and they feel heavier. So, not that that really means anything, but they're roughly the same size and they probably have similar construction. So, I don't know, maybe the electrolytes boil it out of these, or maybe they were always lighter. Couldn't tell you. So I'm going to clean this mess up. I'm going to clean this bar up, give it a nice. Alright, so everything's cleaned up. This is our replacement pile. We got some 22Ks, some 22 ohms, 27K, 22 ohm, 22K, and some 16-volt Zener diodes. Get this nice and polished up. You know, maybe overkill, but hey man, we're restoring, you gotta get into it, you know? You gotta feel it. So, shined up. You can actually see right there. It's clean. That's where the glue is on there. It actually ate away the copper. It's clean as much as it can, unless I like sanded it in half. But nah, not gonna happen. So it's clean. Here's the debris field cleaned up. Yeah, freaking glare everywhere. So yeah, those resistors, Zeners, and crap like that. You have to do some jumpers, which luckily, if the resistors in, they're self-creating. You get jumpers out of them. So I'm gonna do that. Use the old leads to make jumpers out of them. But yeah, everything cleaned up nice. That standing up fusible resistor was actually kind of eaten away. You can see kind of the holes turned black. That usually means the PCB is a little stained just from the corrosion. It didn't hurt anything. It doesn't matter. The pads are fine on the other side, so we're good. So yeah, I'm going to put the resistors in there, the jumpers, the Zeners, and then we can put this bar back. And then we'll continue. So we're back.